from the chapter application of derivative, you will get two questions. One question is from the rate measure. So that is area of a circle, cube, volume of a cube kind of questions you can expect here. Cos of angle between two lines is given by the dot product of B1 and B2 divided by magnitude of B1, magnitude of B2. If you take the modulus of A minus B as an even number, we need to choose any two elements in such a way that their difference under the modulus should be even. Hello everyone, a warm welcome to one and all. This is Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In this session, we are going to find the solutions of the model question paper. So let's take part B section. So you will be given 11 questions. You are supposed to answer any 6 questions out of 11 questions. So let's find the solutions of all the 11 questions under part B section. So the first question will be from inverse trigonometric function. Prove that 2 sin inverse 3 by 5 is equal to tan inverse 24 by 7. So this 2-mark question may be asked proof of 2 sin inverse x, 3 sin inverse x, 3 cos inverse x. Other than that, you can expect questions on principal value branches also, or else you can see the questions of this type, prove that kind. So here, let's take this question now. We have 2 sin inverse 3 by 5 is equal to tan inverse 24 by 7. So let's take the sin inverse 3 by 5 as some theta. Then we'll get sin theta is equal to 3 by 5. Since we need the RHS in the form of tan, sin theta is opposite by hypotenuse, which is 3 by 5. So from using Pythagoras theorem, we get this as 3 by 4. That is tan theta is equal to 3 by 4. We know the formula of tan 2 theta, which can be written as 2 tan theta divided by 1 plus tan square theta. We'll substitute the value of tan theta here. So 1 plus 3 square 9, 16. On solving this, we'll get the value as 24 by 7. So we have tan 2 theta 24 by 7. So 2 theta is equal to tan inverse 24 by 7. Initially, we have taken theta as sin inverse 3 by 5. So therefore, instead of theta, I can write 2 sin inverse 3 by 5 is equal to tan inverse 24 divided by 7. Next question, a question from determinants. So question number 22 is from determinants. They may ask you questions on the equation of line or from the area of a triangle. So here we have the question, find the equation of a line joining 1, 2, 3, 6 using determinant method. So we know that the points when they are given, we can write the equation in the form of x, y, 1, points 1, 2, 1 and 3, 6, 1 is equal to 0. So this is the determinant form of equation of line. So now when we take the determinant value, it is x into 2 minus 6 minus y into 1 minus 3 plus 1 into 6 minus 6 is equal to 0. So here this is 0. So we have here minus 4x minus 2y is equal to 0, or we can write 2y is equal to 4x or y is equal to 2x. So this is the equation of the given line. Next, find dy by dx if y plus sin y is equal to cos x. So question number 23 is from the chapter differentiability. Basically, you can expect implicit form of functions to find dy by dx. So when we have y, the derivative is dy by dx. Derivative of sin y is cos y into dy by dx. Derivative of cos x is sin x. So when we take dy by dx as a common factor, we are left with 1 plus cos y on the left hand side, and right hand side we have sin x. So we need here dy by dx. So therefore this is sin x divided by 1 plus cos y. So derivative is minus sin x. So we'll put minus sin x. Next, find the rate of change of area of a circle with respect to its radius when r is equal to 3 centimeter. So a question from application of derivative. So under 2 marks, From the chapter application of derivative, you will get 2 questions. One question is from the rate measure. So that is area of a circle, cube, volume of a cube kind of questions you can expect here. So now here we have area of a circle with respect to radius. So we know that area of a circle is given by pi r square. We need to derive this with respect to radius. So therefore, dA by dr is equal to pi is a constant. So r square is 2r. Now they have given the value of r is equal to 3. When you substitute r is equal to 3, then the area will be 6 pi centimeter square. Next, find the local minimum value of the function f given by f of x is equal to 3 plus modulus x. X belongs to the set of real number. A question from local maxima or minima. So here we know that modulus x is greater than or equal to 0. It is always positive or equal to 0. So let's add 3 on both sides. Then 3 plus modulus x is greater than or equal to 3. Here 3 plus modulus x is our f of x. So we are getting f of x is greater than or equal to 3. Now in this 3 plus modul x, if we put 0, then 3 plus mod 0 is equal to 3. So instead of 3, I can write this as f of 0, or we have f of 0 less than or equal to f of x. So clearly 0 is the point of minima and f of 0 is 3. So therefore 3 is the local minimum value at the point of local minima 0. Next question, find integral of dx divided by x plus 1 into x plus 2. So this is a question from integration by parts. So we have here 1 by x plus 1, x plus 2. First let us reduce this into simple fractions. So we have 1 by x plus 1, x plus 2 is equal to a by x plus 1 plus b by x plus 2. So taking LCM and equating on both sides, we'll get a1 is equal to a into x plus 2 plus b into x plus 1. Now, equating these things to 0, that is the factors to 0, if we take x plus 1 is equal to 0, then we will get a is equal to 1. And similarly, if we take x plus 2 is equal to 0, then we will get b is equal to minus 1. Now, substituting this here, we can write this as integration dx divided by x plus 1, x plus 2 in the form of a value is 1. So, 1 by x plus 1 dx plus b value is minus 1 divided by x plus 2 dx. So, applying the integration, this is log ax plus b, 1 by ax plus b form, we will get it as log ax plus b. So, therefore, log x plus 1, we have here minus log x plus 2 plus integration constant, or we can write this as log x plus 1 by x plus 2 plus integration constant. Next question, evaluate integral with the limits 0 to pi by 2 sin square x by 2 minus cos square x by 2 dx. Let's take minus outside the integral 0 to pi by 2. Then this becomes cos square x by 2 minus sin square x by 2 dx. We know that cos square theta minus sin square theta is cos 2 theta, but here it is in the form of half angle. So instead of cos 2 theta, we can write cos theta, but x is given here, so we can write it as cos x. Using trigonometric identity, we can write this as cos x dx. Now integral of cos x is sin x. Now let us apply the limits from 0 to pi by 2. So we have minus outside. Sin pi by 2 is 1 minus sin 0 is 0. So the value of this integral is minus 1. Next question, find the projection of the vector A on the vector B. So the projection of vector A on vector B is given by A dot B divided by magnitude of vector B. A dot B means just multiplying the scalar components. So 2 1s are 2 plus 3 2s are 6 plus 2 1s are 2 whole divided by magnitude of vector B is 1 square plus 2 square plus 1 square. So here we have 10 divided by root 6. Next question. Find the angle between the pair of lines given by vector r is equal to 3i plus 2j minus 4k plus I plus 2j plus 2k and 5i minus 2j plus mu 3i plus 2j plus 6k. So we have here vector b1 and vector b2. This is vector a1 and this is vector a2. So cos of angle between two lines is given by the dot product of b1 and b2 divided by magnitude of b1, magnitude of b2. So we have vector b1 and vector b2 is, so let's take the dot product of the scalar components with respect to I, j, k. So 1 into 3, 3 plus 2 into 2, 4 plus 2 into 6, 12 whole divided by magnitude of vector b1 is 1 square plus 2 square plus 2 square and magnitude of vector b2 is 3 square plus 2 square plus 6 square. So here we have cos theta is equal to 19 divided by root 9 which is 3, root 49 which is 7. So theta can be written as cos inverse of 19 divided by 21. Next one, a fair die is rolled. Consider the events E135, F2, 3. Find P of E conditional F. So P of E conditional F is given by P of E intersection F divided by P of F. So this problem can also be used with another formula, that is number of elements in E intersection F divided by number of elements in F. First let us find E intersection F elements. So the common element is only 3. So therefore here number of elements in E intersection F will be equal to 1 and number of elements in F will be equal to 2. So this can also be written in the form of 1 by 2. If you take the probability value, then here 1 divided by 6 divided by 2 divided by 6 which will be equal to 1 by 2. So therefore conditional probability can be used with the help of probability also or with the number of elements in E intersection as well as F. Next, if A and B are two events such that P of A is 1 by 4, P of B is 1 by 2 and P of A intersection B is 1 by 8. Find P of not A and not B. So clearly they have not mentioned whether they are independent or not. So now since we have to find out P of not A and not B, that is P of A dash intersection B dash. Using De Morgan's law, we can write this as P of A union B whole dash. And the complement of the set can be written as 1 minus probability of A union B. We know that probability of A union B is P of A plus P of B minus P of A intersection B. So let us subtract these value from 1. So we have 1 minus 1 by 4 plus 1 by 2 minus 1 by 8. So on solving this, we will get the value 3 divided by 8. Which is 1 minus 5 by 8, which is 3 by 8. Next. So from question number 21 to 31, it's question only for 2 marks section. So we have solved all the 11 questions in your model question paper. Let's move for part C section, which is questions from 3 marks category. So here also you will be given 11 questions, but you are supposed to answer any 6. But now I am solving all the 11 questions. Show that the relation R in the set A 1, 2, 3, 4, 5 given by R is equal to mod A minus B is even is an equivalence relation. So clearly if you take the modulus of A minus B as an even number, we need to choose any two elements in such a way that their difference under the modulus should be even. So now if I take 1, 1, 1 minus 1 is 0. 0 is considered as even. If we take 2, 3, 4, 5, obviously A minus A, 0 is even. So clearly A, A belongs to R. So therefore R is reflexive. Now let's take any two elements. A, B belongs to R. Let A, B belongs to R. So this implies modulus A minus B is even. Let's take the negative here, then it becomes B minus A. So which is even again. Any negative number under the modulus becomes positive only. So mod b minus a is even. So this implies b comma a belongs to R. So for any a comma b belongs to R, we have b comma a belongs to R. So therefore we conclude R is symmetric. Now let's check the condition for transitive. Let us take three elements a, b, c such that a comma b belongs to R and b comma c belongs to R. So this implies mod a minus b is even and mod b minus c is even. So when we take the sum of any two even numbers, it is obviously an even number. So here minus b plus c, b cancels. So this implies mod a minus c is even. Now according to the condition, if mod a minus c is even, then a comma c should be in R. So for any a, b, c satisfying the condition, we are getting a comma c belongs to R. So therefore we conclude R is transitive. Now we have R is reflexive, R is symmetric and R is transitive. So hence R is an equivalence relation. So therefore now you can see here the question number 32 will be from the chapter relations and function, and it is basically a question from equivalence relation. Next we have write the simplest form of tan inverse 1 plus x square under the square root minus 1 divided by x where x is not equal to 0. A question from inverse trigonometric function. So I have already told you under 3 marks you can expect the simplest form of inverse trigonometric function. Now let us take the substitution for x. I'll put x is equal to tan theta here. Now if I substitute, then we get tan inverse 1 plus tan square theta minus 1 whole divided by tan theta. So clearly 1 plus tan square theta is secant square theta and under the square root it is secant theta. So we are left with tan inverse secant theta minus 1 by tan theta. Now let's take the substitution of secant as 1 by cos, tan as sin by cos. Then the equation becomes tan inverse 1 minus cos theta divided by sin theta, and solving because the denominator is cos which get cancels for both numerator and denominator. Let's use half angle formula here. We get tan inverse of 2 sin square theta by 2 and sin theta as 2 sin theta by 2 cos theta by 2 which cancels here, and sin by cos we get this as tan inverse of tan theta by 2. Now tan inverse of tan theta is theta under the given domain and range. So therefore clearly this can be written as theta by 2. But what is theta? So we have taken here x is equal to tan theta. So theta can be written as tan inverse x. So therefore the whole equation is reduced into half tan inverse x. Next question, question number 34. So here there is a question from expressing a matrix in the form of symmetric and skew symmetric matrix. So other than that, we have few theorems in the chapter matrices. So that can also be asked under part C sections. So now here we have A, we need to express A in the form of P plus Q, where P is half of A plus A dash and Q is half of A minus A dash. And also P should be symmetric, Q should be skew symmetric. So let's prove this. Let's find A dash now. A dash is 3, 5, 1, minus 1. Now let's check for P. P is half of A plus A dash. If we add A plus A dash, we'll get P 6, 6, 6, minus 2. So which after reducing 3, 3, 3, minus 1. Now let's take P dash here. If we take P dash, it is 3, 3, 3, minus 1, which is P. So clearly P is symmetric matrix. Let's find for Q. So Q is equal to half A minus A dash. When we subtract A minus A dash, 3, 3, 0, 5, 1, 4, 5, 1, 4 again. So minus 1 plus 1, 0. So we are left with half, 0, 4, minus 4, 0. After reducing, we will get this as 0, 2, minus 2, 0. Now let's find Q dash. Q dash is 0, 2, minus 2, 0. By taking negative outside, we will get this as 0, 2, minus 2, 0. That is equal to minus Q. So we are getting Q dash is equal to minus Q, which means Q is skew symmetric. So therefore, A is equal to P plus Q. That is 3, 3, 3 minus 1 plus 0, 2 minus 2, 0, which is equal to 3, 5, 1 minus 1. Hence, we proved. Next question. Differentiate sine square x with respect to e power cos x. A question from parametric form. So, we need to differentiate these two functions. Both are in the variable x. So, let's take two different variables. I'll consider u is equal to sine square x and v is equal to e power cos x. So, now here du by dx is equal to 2 sin x cos x and dv by dx is equal to e power cos x into minus sin x. Both are functions in the composite form, so we should use chain rule. Now we need du by dv. So by dividing this, 2 sin x cos x whole divided by e power cos x minus sin x. So we can cancel sin. Therefore, the answer is minus 2 cos x divided by e power cos x. Next question. Differentiate x to the power sin x greater than 0 with respect to x. So, here we have two variables in the index form. So, therefore, let's take y is equal to x to the power sin x. If we apply log on both sides, we will get log y is equal to sin x into log x using the property of log. So, this is from logarithmic function. So, let's apply log on both sides and we are deriving it. So, we get here 1 by y dy by dx. We have product here. So, let's apply the product rule. First function, derivation of the second plus second function, derivative of the first. Now, clearly dy by dx. This y can be shifted here and y is x to the power sin x. So, this is x to the power sin x divided by x log x into cos x. Next question. Find the interval in which the function f of x is equal to 10 minus 6x minus 2x square is strictly increasing. So, the question number 37 will be from application of derivative on increasing and decreasing functions. So, here we have a function. Let's take f dash of x. Then we get minus 6 is equal to minus 4x. To find the interval, we need to find the critical point of the function. So, we will put f dash of x is equal to 0. So, we get minus 6x minus 4x is equal to 0. We will get x is equal to minus 3 by 2. Now, in the entire set of real numbers, from minus infinity to plus infinity, we will divide the interval here. So, the interval minus infinity comma minus 3 by 2. Here, f dash of x is greater than 0. So, clearly in this interval, f is strictly increasing. So, why f dash of x greater than 0? Because we have minus. So, minus and minus of the extremes, which is nothing but plus. So, it's greater than 0. So, obviously, f is strictly increasing in this given interval. So, if they ask us to find the decreasing, we'll write the another interval, that is minus 3 by 2 comma infinity. So, here f dash of x is less than 0 because the extremes is minus and plus, which is less than 0. Minus into plus is minus, which is less than 0. So, here the function will be decreasing. Next question. Question number 38. Find integral of x into sine inverse x dx. A question from integration by part. Before that, we have a rule called ILATE, ILATE. So that means the order of the function should be written before applying the integration by parts. So we can also rewrite this function in the form of sine inverse x, or else we can also use the method of substitution to solve this integration. So here I'll take theta is equal to sine inverse x. Then sine theta is equal to x. Let's derive this. Then cos theta d theta is equal to dx. Let us substitute this in the given integral. Then the integral becomes integration of sine theta, sine inverse x can be written as theta, dx can be written as cos theta d theta. Let's keep theta as it is. Sine theta cos theta can be written as sine 2 theta by 2. Sine 2 theta divided by 2 into d theta. So let's take half outside the integral, theta into sine 2 theta. So now here we can apply the integration with respect to d theta. Let us apply the rule keeping half outside the function. So first function, integral of sine 2 theta d theta minus integral of derivative of theta with respect to theta, integration of sine 2 theta d theta with respect to d theta again. So if we derive this, we have half theta minus cos 2 theta divided by 2 minus integral of derivative of theta is 1. Again integration of sine 2 theta becomes plus cos 2 theta by 2 with respect to d theta again. So now we have half minus theta by 2 cos 2 theta, here plus sine 2 theta divided by 2 is already there, so which becomes 4 plus c. So now let's multiply half here. So minus theta by 4 cos 2 theta can be written as 1 minus 2 sine square theta, because since we have taken theta in the form of sine, now let us apply everything under sine. So let us convert cos 2 theta as 1 minus 2 sine square theta, and sine 2 theta can be written as 2 sine theta cos theta. Now 1 by 2 into 1 by 4 is 1 by 8 into 2 sine theta cos theta plus c. So here it cancels. So we have here minus theta is nothing but sine inverse x. So let's multiply sine inverse x divided by 4, 1 minus 2x square plus 1 by 4. Sine theta is nothing but x. Cos theta can be written as root of 1 minus sine square theta. So therefore this can be written as x into root of 1 minus x square plus c. So this is the value of the given integral. Next question, find the equation of the curve passing through the point minus 2, 3 given that the slope of the tangent to the curve at any point x, y is 2x divided by y square. So this is a question from differential equation. A few statement problems under variable separable method can be expected for 3-mark question. So they have given slope of the tangent is equal to 2x by y square. Slope of the tangent is given by dy by dx, that is equal to 2x by y square. Now we have y square into dy, 2x into dx. Let's separate the variables and then integrate it on both sides. Integration of y square is y cube divided by 3. Integration of x is x square by 2 plus c. So therefore this is y cube by 3 is equal to x square plus c, or we can write y cube is equal to 3x square plus 3c. Next question. Show that the position vector of the point P which divides the line joining AB having the position vectors vector A and vector B internally in the ratio m is to n is m vector b plus n vector a whole divided by m plus 1. So this is a section formula, very important question. So let's draw a line AB, point A, point B. Let's take an origin O. Let vector A OA and let vector B be OB. P be any point on the line segment AB whose position vector is R. So from this figure we can write vector OA is equal to A, vector OB is equal to B, and vector OP is equal to vector R. Since A, P, B are collinear, we can write AP divided by PB in the ratio m by n. So let's take the ratio mn here. So then AP can be written as OP minus OA, PB can be written as OB minus OP, that is equal to m by n. Let's substitute these values here. Then we get vector R minus vector A divided by vector B minus vector R is equal to m by n. Cross multiplying this, we get nr minus na is equal to mb minus mr. So mb plus na is equal to m plus n into vector r. So therefore vector r is m into vector b plus n into vector a divided by m plus n. So this is the position vector of the vector r. Next, find a unit vector perpendicular to each of the vectors a plus b and a minus b, where vector a is 3i plus 2j plus 2k and b is I plus 2j minus 2k. So let us find the unit vector perpendicular to these vectors. So when we are finding the unit vectors, then it is always a vector divided by its magnitude. So let's find a plus b and a minus b. If we find a plus b, let's add the scalar component with respect to I, j, k. So we get 4i plus 4j plus 0k. Vector a minus vector b is 2i, 0j and plus 2k. So let's take vector c to find the unit vector of these two vectors. Let this be the cross product of vector a plus b and vector a minus b. So we know that the cross product can be written in the form of determinants. So I, j, k. Let's write the components 4, 4, 0, 2, 0, 2. So let's solve this. We have I into 8 minus 0 minus j into 8 minus 0 plus k into 0 minus 8. So we get this vector as 8i minus 8j plus 8k equals 3i minus I is 2i, 2j minus 2j is 0, 2k minus of minus 2k will become 4k. So now let's find the cross product of these two vectors, that is vector a plus b cross a minus b. So let this be some vector c. Now we know that the cross product of the vectors can be written in the form of determinant, so which is I, j, k. Now the components 4, 4, 0, 2, 0, 4. So here we get 16i minus, next we have 16j plus minus 8k. So therefore vector c is 16i minus 16j minus 8k. So we can take 8 as a common factor, then we'll get this as 2i minus 2j minus k. Now let's take the magnitude of vector c. Magnitude of 8 is 8. So square root of 2 square plus 2 square plus 1, which is root 9, 3, 8 3s are 24. So now we need the unit vector C cap, which can be written as vector C by its magnitude. So we have 8 into 2i 2j k whole divided by 24. So we get the answer as 1 by 3 into 2i minus 2j minus k. So this is the unit vector perpendicular to both the vectors, vector a plus b and vector a minus b. Next, the last question under part C section, question number 11, which is in the form of 42 in the question paper. A bag contains 4 red and 4 black balls. Another bag contains 2 red and 6 black balls. One of the 2 bags is selected at random and a ball is drawn at random from the bag, and it is found to be red. Find the probability that the ball is drawn from the first bag. A question from Bayes' theorem, a fixed content of question number 42 from the chapter probability is Bayes' theorem. So now here for the given question, probability of choosing bags, let it be E1 and E2. So we have probability of choosing bag 1 is 1 by 2. Probability of choosing bag 2 is 1 by 2. Now let's choose red from bag 1. So let choosing a red ball be an event A. So probability of choosing red in bag 1 is 4 out of 8 because we have 4 red and 4 black. So 4, 8, which is 1 by 2. Similarly, probability of red ball in bag 2 is again total 8 and 2 red, which is 2 by 8, which is equal to 1 by 4. Now we need to find the probability of the ball drawn is from the first bag. That is, we need to find the conditional probability of E1 over A. Now using Bayes' theorem, probability of E1 over A can be written as P of E1, P of A over E1 divided by the total probability, that is P of E1, P of A over E1 plus P of E2, P of A over E2. Now here, let us apply the values. So we have 1 by 2 into 1 by 2 whole divided by 1 by 2 into 1 by 2 plus 1 by 2 into 1 by 4. We can remove all 1 by 2 here. We are left with 1 by 2. So taking LCM here, denominator is 3 by 4. On solving this, we will get the value as 2 divided by 3. So therefore, probability of E1 over A is 2 by 3. In this session, we have solved the solutions under part B, part C section. So in the next session, we'll be solving part D and part E section. I'll meet you in the next session. Until then, keep watching, keep learning and keep exploring. Thank you.